adresse Pensée vient de Russie et qui dans quelques semaines va changer d'horizon pour aller au Sénégal à Dakar et qui va nous présenter les travaux qu'il a réalisés sur des techniques que l'on a un petit peu vues en réalité avec une présentation junior il y a quelques semaines, mais ça sont plus étendues. Donc merci de cette présentation.
Bonjour, je me présente, je suis Pavel Ratmanov, je suis un chercheur contractuel à l'IRD, attaché à l'ORMIT depuis septembre 2011. Excusez-moi, je ne parle pas français encore, mais je vais faire de mon mieux pour l'apprendre bientôt et je vais faire mon rapport en anglais. I will speak, I will deliver my report in English. I would like to begin my report about from. My native region is the Russian Far East. It's a very huge territory. The distances between towns are very huge and infrastructure is very lacking and very much of the Russian Far East and France at the same scale. A couple words about me. I graduated from the medical university in 1998 and gained degree Doctor of Medicine. Then I had residency in epidemiology, public health and health services management. In 2002 I defended my dissertation and became PhD. For the last 10 years I was associate professor at the Department of Epidemiology, Public Health and Health Services Management in the Khabarovsk Medical University. And I have research experience in epidemiology and biostatistics, geographic information systems in public health, and I am interested in the history of medicine and the history of epidemics. My report will be divided in two parts. The first part I will talk about the GIS in public health and epidemiology, some general issues, and the second part, small part, will be dedicated to my project here in Permit. What is GIS? GIS is a Geographic Information System. Although there is a French term SIG, Système d'Information Géographique, some kind of synonyms. There are a lot of definitions what is GIS. I have chosen Geographic Information System is a computer information system that can input, store, manipulate, analyze, and display geographically referenced or spatial data to support decision-making process. I would like to emphasize the words geographically referenced data. It means spatial data. That GIS manipulate with the spatial data. Almost everyone here use some kind of maps in their presentations. Usually we search the maps in internet, download it, and some kind edit it in graphical editors and insert these maps into our presentation. This is not GIS because these our small maps are not geographically referenced. They don't have reference to geographical coordinates XY. So I would like to emphasize this because it's a principal difference between geographic information system and vector or raster graphic editors. And almost everyone here used GIS before because in recent years there was an explosion of internet GIS, like Google Maps, Google Earth, or Bing Maps, that these are GIS because they are geographically referenced. And if you want, you will find the coordinates of every point in Google Earth. GIS in public health and epidemiology were implemented several decades ago. And, but it's not absolutely new area. Previously, this field named as magical geography, and it has very long history. Here is a Hippocratic treatise and the very famous treatise on the airs, waters, and earth, like maybe first example of medical geography in the history. This treatise was written about 2,400 years ago. And medical geography is a field of research that incorporates medical techniques into study of the spread of diseases. In addition, medical geography studies the impact of climate and location on health and the distribution of health services. And medical geography provides an understanding of health problems based on the geographic factors and try to improve the population of the health populations. There is a classical example of GIS in public health. There is Dr. John Snow, maybe pioneer in this area. You can find this case maybe in every book on GIS in public health. Dr. John Snow is an English epidemiologist, public health specialist, and anesthesiologist. In 1854, there was a vigorous cholera epidemic in London, especially in Soho district. And Dr. John Snow, he plotted the cases of cholera on the map of London. And he discovered the cluster that major part of these cases was in the district of Broad Street and near the water pump on the Broad Street. And this map approved his theory of that drinking water, contaminated drinking water was the cause of the cholera outbreak. And when he had authority to close this water pump, the number of cholera cases dramatically decreased. And there is another example from the history. One of my previous research was the history of Russian medicine in China in 20th century, historical, scientific, social aspects, history of colonial medicine in China. And my research included the history of epidemics of pneumonic plague in northern eastern China in 1910, 1911. It was a very huge epidemic. There was about 100,000 victims only 100 years ago. And there was 100% mortality, and there is a map adopted by me in GIS, but it's a historical map composed 100 years ago, and there is a transmission of the epidemics from Manchuria, Chinese town in the border to Mongolia, and the plague transmitted to east and to south, and the Chinese Russian authorities tried to block epidemic by blocking railway, but the epidemic just passed by the railway. Our study revealed that traditional European sanitary countermeasures were not effective in China because of tradition, religion, customs, and suspicion to European medicine 100 years ago. And there was victims among Chinese physicians, Russian physicians, and there was one victim of a French physician, Dr. Gerard Mini from Tianjin, from Imperial College, Medical College in Tianjin. Now we return to nowadays, to GIS. What GIS can do? GIS integrate many different types of data. Spatial data, geographically referenced, and non-spatial data. For example, statistical and texts. With the GIS, we can easily draw maps and visualize spatial distributions, edit existing data, measure distances and areas, overlay maps of different areas. There is example, it's my map, it's in Russian, I'm sorry. This map demonstrates the location of healthcare resources, first aid station, rural clinics, central hospitals in Magadan region. It's a region very close to border, northern region in the Russian forest. This slide shows how table data could be converted into maps. Usually we have just table data and numbers, and with the GIS, these numbers convert into maps with charts. There is example, Senegalese village in Guillemot, and the prevalence of Triphalema week. How can GIS, Geographic Information System, could help the public health? By determining geographic distribution of diseases, by analyzing spatial and temporal trends, mapping population at risk, stratifying risk factors, assessing resource allocation, planning and targeting interventions, and monitoring diseases and interventions over time. There is another example. It's another kind of map, thematic map. It's a choropleth map. It's a Khabarovsk region, my native region. This map demonstrates the patient flow from remote areas to central hospitals. And every district shaded by different color depending on the grade. It's a widespread kind of thematic map. It's a choropleth map. Geographic Information Systems have the following application in epidemiology: data visualization and exploration, data integration, monitoring, geostatistics and modeling, spatial interaction and diffusion, data sharing, and web services. There is another example. It's a borrowed map, not mine. I found it in the PubMed. It's an example how modern techniques could be applied to historical case. Map A, this is a classical map of Dr. John Snow. You have seen it several slides before. It's a map of Soho district in London, and water pump